So when it's time to draw vertical lines, lines that go up and down, we're not going to use the T-square on the bottom edge of the table or at the top edge. The T-square always stays in its horizontal orientation like this. What we're going to do is we're going to look for another tool that's in your toolkit, and it's called a triangle. If you look at it, it is a plastic triangle. It might be clear or tinted blue or light gray. Mine's got a little handle on it, so it's easier to pick up. But the idea is when I want to make vertical lines, I want them to be perpendicular to horizontal, right? And the T-square is horizontal. So here's how this works. We take our triangle, we put it on top of the T-square, right? So it's riding on the horizontal edge. Make sure that your head on the T-square is against the drawing board. What you're going to do is you're going to hold the T-square so it don't move, and you're going to slide the triangle to where you want that vertical line, and then you'll create the vertical line. Alright, so lines that are vertical need to be parallel to each other, and they will be as long as the triangle is riding on top of the T-square. Because this is horizontal and this is 90 degrees to it, these lines will always also be parallel. Because if that is horizontal and we work off of it, we'll never get lines that are converging. What you don't want to do is this. You don't want to take away your T-square and pick up your triangle and say, oh, that looks straight, and then try to draw a line. Because guess what? It's not straight. It'll never be straight. It's going to be off. It's like trying to eyeball things in CAD. It just doesn't work. If you want to make it make it a little more easy to understand, the T-square is Batman. Now, Batman is cool. Batman's got his own movies, right? The triangle is Robin. See? Batman was fine before Robin. Batman could be in a movie without Robin. Robin, not so good. He needs Batman. Without Batman, Robin's really nothing. So don't use the triangle to make vertical lines unless it is sitting on top of your T-square. And again, I know this is doing multiple things at once. You see, I'm using my palm to hold down the T-square. I'm using my fingers to position and hold the triangle, and then I'm using my other hand to do the drawing. So I'm actually trying to do three things here at once. That is a little tricky, but we get used to it after we practice a little bit. Just like when we were making horizontal lines, we wanted to lean the pencil in the direction we were going, right? Well, we're going to do the same thing here. When we're making vertical lines, we're going to lean the pencil in the direction we're going. So I'm starting at the top and leaning down because I'm traveling in that direction. Okay, and you want to give it a little twist too while you are drawing. Keeps the pencil tip a little bit sharper, a little bit longer. Okay, don't lean to the left or lean to the right when you are drawing on a triangle, because if you do, again, it's easy to rock back and forth and not pay attention, and suddenly you have lines that are not perfectly straight anymore. They're not perfectly perpendicular to the lines that they're sitting on with horizontal. You have one triangle that is a 90-degree corner here, and a 45-degree corner here and here. This is called a 45, 45, 90-degree triangle. The other triangle in your toolkit is much skinnier and longer. It is a 30, 60, 90-degree triangle. So why only two triangles? And why doesn't our drawing kit have a protractor? Well, the fact is, if you look around at manufactured things, if you look around at buildings and the built environment, it's just really easy to build things at 90-degree angles, right? Yeah, you take a circle, you break it into four, you get 90-degree increments. The corners on buildings and inside rooms, on the ceiling and on the walls, right? Aren't they usually 90-degree corners? So we need to be able to draw things at 90 degrees. 45 is half of 90, and we're able to take 90 degrees and break it into two equal parts very easily with 45. Right, so that's our equilateral triangle here. 45, 45, 90. How come 30 and 60? Well, six-sided objects use 60-degree increments, and 60, 30, 45, and 90 are the most common angles we're going to be using for manufactured and fabricated parts, by far. So, with these two triangles, we really knock out the majority of angles we need to make with standard, typical, technical drawing work. And believe it or not, with these two triangles, we can make 24 different angles. Okay, so we start with a horizontal line, and then we bust out our triangle, either one, and then we've got a 90-degree quarter. Right, so that's going to give us four 90-degree angles there. And then we can take our 90 and bust our 90s in half with 45 degrees in both directions. Alright, and now there's 8 angles. And then I can take my 30, 60, 90 and go 30 this way, and 30 that way, and then 60 this way, and 60 that way. Alright, and then with a little piggybacking, I take 45 and I add 30. See, this gives me a new angle. This gives me 75. So I'm going to slide that over and knock those two out. And I'll do the same thing on the other side. Degrees. And then if I flip things around a little bit, 45 minus 30 gives me 15 degrees. So I'll knock out my last two angles here. Here. One over here. Let's see, how am I going to do this with my, there we go, with my little push pins. Alright, so 24 different angles using the two tools with a little bit of addition and subtraction, and we're going to be able to hit every angle we could possibly ever need in this class, or with most typical standard fabrication and manufacturing drawings with the two triangles.